Hi there. This is Adam Wolf, and you are watching Farming Fast and Slow here at the hunkered down headquarters of Princeton, New Jersey. And Walter, where are you calling in from?
I'm calling in from Albany, California. So
Albany, California,
here,
famous
yeah.
for its bowling alley, and in this case, for its API development uh, for Arable Labs. And so this week, we're actually going to talk about how to access the API of Arable, where the documentation is, and Walter's going to show you some examples. First, just some housekeeping. This will be, half an hour discussion with some Q&A afterwards. This being Zoom, if you look down there at the bottom, you're going to see like a little Q&A section. And so we'll be able to look at those questions when you post them. And then afterwards, this is going to be located at arable.com/farming fast and slow. And this particular episode also has a GitHub component, which we'll be posting as well. So I guess to start off, Walter, tell me about yourself. Where did you come from?
Well, thanks for
And
having
what do
me.
you do here at Arable?
Yeah, so let's see. I come from Venezuela. Moved to the US about almost 6 years ago. Um, as I was, moved here, then started going to school here. I went to UC Berkeley. My last year, I heard about Arable. I thought seemed like a cool company. Still, it's a cool company. I started working as an intern during my last year, and now I've been almost a year as a full-time employee, so almost 2 years total.
And what made you start? You're in customer success, so you're working with people who bought the product. What made you start typing up code to talk to the API?
Well, I think from day one, the exposure to more computer science concepts and working directly with researchers, as an intern, like from day one, kind of got me into the groove of like having to understand what is an API to begin with, how it works, how a particular API works, working with V1, and then working with the earlier client that we had in Python and so on. So basically serving and understanding requests from researchers and integrators kind of had me have to dig into what an API is and how to work it.
Yeah, I mean, you're using a lot of words that may or may not be familiar to a bunch of people. So we'll unpack that in a little bit. But I think the reason why I think you're the perfect messenger for this is, you're not a software engineer and you're not a, plant biologist, but you're somebody who is, let's call it code adjacent, being kind of quantitative as an economist. And, everybody that you interact with grows plants for a living, and so to some extent that means understanding how to turn those plants into numbers and turn those numbers into something that is like an analytic. And that for me is one of the key kind of audiences for us in Arable is, this group of folks that may know a bit about how to write code, but want to know more about plants. And this other group of people that might know a bit about plants and, wants to learn how to turn that into code. You happen to be neither of those, but you're like right in the middle trying to tackle both at the same time. And so one of the pieces that I think is really interesting here as we get into it is one, this piece of code that talks to our API. So it's sort of, there's a database sitting in the cloud, and all that data that is being collected by these devices is up there in that database. And so we want to talk to it. And then that's, maybe interesting in and of itself, but it's more interesting if we relate that data to each other, and maybe try to make some correlations and then turn those correlations into decisions. And so you're going to be using the Arable physics library for part of this to say, okay, well, we've got some of these data and we can turn some of these numbers into other numbers that are useful. So it's, gosh, if I know the temperature and the humidity, I can calculate the dew point. Actually, all I need to know is the temperature to know the dew point. But I wonder if we might just kind of dive in to the work that you did and maybe discuss it live. Is there anything else that you want to prep us for?
Sure. No, I think it's better if we go through it and discuss it and go through some practical examples probably.
And do you have what's the sort of user you have in mind when you developed this?
I think mainly, well, at first, very selfishly, I was thinking of my own needs, but as I was developing, I realized that probably there's more catered towards researchers who are the ones who tend to come and ask a lot more about clients and to communicate and get data from our database. So I think the functions that I've developed tend to cater more towards researchers who are trying to um, explore their data, clean it, plot it, so on and so forth. So I think that would be probably my primary audience when I was thinking about this.
Sure. So the app satisfies some people's needs, but then there's a whole category or many categories of needs that are not met by the app. And some of that includes kind of this open-ended data exploration or prototyping. And that, I think, is what yours is oriented for, is really out there on the edge. And since the very start, we've embraced the idea that you can open up the hood and see what's inside the data. And so how about if you open up the hood for us?
Sure. Let me share my screen.
Okay, so what are we looking at here?
So we're looking at the developer side. If you are not familiar with it, it will be probably a good start to go there and check it out because I think it's pretty neat and we have a really good documentation for the API that we're going to be using. So in case you want to modify the client or make your own, you just come to the API documentation. You're going to find everything you need to know about the type of authentication and what are the endpoints that you need to use to make your own client, modify the one I've made, so on and so forth, and see that's the features that you can use and add and all the things that you can do with their data. So I think that's a good first step. Then here I have this Arable examples repo that, well, we're going to be sharing the link to it. Here you'll find everything about this API client, Python client that we're going to be discussing today. There's a fairly good README first. You'll see how to install it. The basic quick start guide, and then what do you need to do to make your first data query, and the parameters that we use, and you can put them in the query as well. So everything is right there.
Nice. And what I like about your work on this is it used a really common code stack that I think of as the PyData stack that uses Python, NumPy, Pandas, and Matplotlib, along with requests library talking to the API. And so this is useful for me because, on the one hand, it's easy to kind of prototype all this data stuff, look at visualizations, but also you can find servers and things like that that would, create a way to view this as an app. And so it is kind of flexible in a way that many other languages are a little bit narrower. So, okay, so we've got the link. We'll be sharing that later on, but maybe do you want to sort of take us through some of the steps of how this API works?
Yeah, definitely. So I want to walk through, I added this examples, Jupyter examples here. I think for most researchers, it's a great tool. I think most of the researchers I've worked with are aware of Jupyter Notebooks. Otherwise, you should check them out. It's sort of interactive way of looking at your at your Python code. So it's great for maybe an early development or also just exploring and operating on data. So there's 3 examples that we're gonna go through today. The first one is kind of looking at what's happening in the client itself, like how the authorization is happening. So basically how we're passing the headers that we use with our credentials to then make the calls to get the data that we need. The next one will be sort of an easy example of how to query data and some other features that the client has. So you can access some data dictionaries, so you can access all devices you can see and so on. And then the last one will be sort of putting it all together, will be plotting some of the data in kind of cool ways that you could just do using this client for now. So let's probably move to Jupyter here. So in this first example, these are, I think, 2 basic functions that are within the Arable client class and inside the client. We use them to basically get authenticated. So we pass our email or credentials that are later going to be encode. And then if we pass the right credentials, then we're going to be able to start calling and making requests to our database. So
are those, tell me about the username and password, the email and password. Is that just what anybody gets when they buy the device, their kind of default username and password?
Correct. So when you become a customer, you get a device or you're part of an org already that has a device and someone invites you, you will get credentials. These are the credentials that you will pass, and you will see the devices that either, if you are the org admin, you will be able to see all of the devices, or if you've been assigned a device by your org admin, then you will see the devices that you've been allowed to see. So yeah, when you pass your Arable credentials that you receive the minute you sign up or someone invites you, you will pass these credentials here to use it. So, well, this is a classic Jupyter Notebook. We first have a cell in which we have, we're importing some libraries, Python libraries that we use here. So the first one, well, the baseline code that in this case we're using within the client, like you would not normally use this if you were using the client. Then pandas, that I think is an amazing tool for exploring, cleaning data. I use it all the time. I think most of the researchers that I've worked with also use it. And 2 other libraries that we're going to use to show how to make requests to the via API. So I'm going to go ahead and run that. And then you'll find there's 2 functions, as I said, within the client. The first one is connect. We're going to pass, in this case, we're going to pass 2 arguments to it. The first one is going to be our email, second password. This would be all stored within a class, so you wouldn't see the header variable as global. It will be part of the class.
This is what's inside your client that we'll use elsewhere. So we're just kind of peeking inside to see, for example, I can see in the next function the URL for the API itself.
Exactly. So in this case, we pass the email, we pass the password. If we don't, the first thing that the function is going to do is, well, if we don't find it, we're going to give you, we're going to raise an alert. Hey, like you didn't pass the right parameters. You need to enter the email password or API key. If this exists, then we're going to go ahead and actually go and use another function, which is the logging function. We're going to pass the email and password to it. We're going to move down here. And in this case, well, we're going to use the URL that we have. This is this all the way here would be the base URL for our API. After that, we're adding to it to make the calls and reach the endpoints that we need. The next thing we're going to do is we're going to base 64 encode the credentials that we pass, the email and password.
And that's just to obscure your username and password when we're passing it over the network.
Well, I understand base 64 encode shouldn't be used to obscure or encrypt. It should be more, it's like a safe, well, not quite safer, but a more efficient way of sending the data to, well, in this case, to our server or via the API.
Okay.
But it shouldn't by no means be used as a security format because it's very weak in that sense. It's not like a secret. Anyone can just look it up. So yeah, shouldn't be used for security purposes, but more this the protocol that it's used, right? So well, then once it's encode, we in this case we're using a type of authentication that is called basic. So we're just using the email and password. And this function, what it does to check that you indeed pass the right credentials, is that we're going to make a quick get request using the devices endpoint to our API. So we're going to use this URL. And what this endpoint does, and we can also look this up in the API documentation, is basically show you the devices that you can see. And what we do with this is we pass this URL, we pass a header, which in this case is the basic authentication using our credentials that we already encode. And if for this request, we get a status code of 200, which means that it passed, then we know we have the right header to make all the calls that we're going to be making in the future. So if we do get it, if we do get 200, then we're good. We keep that header. So this variable header will now contain our credentials, and we're going to keep it for our purposes, right? So let's run this. And now here I'm passing my Arable email and my Arable password to the connect function, the first one. And that, as I said, will go to the login, check, we'll encode it, pass it to this endpoint, and then see if we get a 200 code. In this case, we do. I'm also printing the header, so you know sort of like what it would look like. So now the variable header contains my credentials, and this is gonna continue to be there. And basically in that instance of the Arable client, we're gonna keep the header, and every time we make a call, actually what I've included in every single function is basically in the beginning, you're gonna check the connection, which is to see if you have a header, then you're good to use that function. That's what will allow you to use the function. Otherwise, we'll tell you that the authentication, that you're not connected, basically. You're not logged in, if you will. So this, in this case, is true because like that we have a header and it's this, and to have a header, it had to pass in the first place. So we're basically logged in. And that's kind of like what's under the hood, like before we go into, well, all the endpoints and how to, like the endpoints to actually query data and see data is being authenticated.
In my experience, the authentication part is the hardest piece of, you know, writing the API. And from there, once you get the header correct, then you can kind of poke around among the endpoints and get the data that you want. So maybe should we go over to the data query example?
Yeah, sure. Okay, so now we have another one. It's a great example. Then now we're past the authentication. We're actually just gonna query some data and see some other things that we can do with the client, some functions we can do with the client. So first off, we're gonna need a couple libraries that if you haven't installed, I would recommend doing so. Pandas being the first one because we wanna be able to read and see and operate on the data that we're going to be getting, the tables that we're going to be getting. So I think pandas is the best option in Python. Then for plotting, I personally like Seaborn and Matplotlib. We're going to see that in the next notebook. And if you haven't done that, you don't have to go to a terminal. You can actually run it here in another cell. You use the exclamation point first, and then this will basically run it in the terminal. So you can install it right here. So the first thing we're going to do is make sure we import the Arable py library that we've installed using Git.
So that whole set of examples for the authorization is included in that Arable py folder.
Correct. Yeah, everything will be there. We don't have to worry about that anymore.
All right.
Awesome. Then we're gonna import pandas. It's customary to import it as PD. In this case, because I'm getting my password and email from an environment, system environment, I'm using OS, but you probably would just omit that and just write your own. NumPy is another good library to have when you're making mathematical statistical operations in your data. I would recommend. And then the Matplotlib, Seaborn. And then also I would recommend importing datetime because we want to convert the time columns that we're going to get as datetime objects. That would be easier for, well, again, exploration, operation, plotting of the data. So I would recommend that. So we make the imports. Then the first thing we're going to do is create an Arable client instance. So we're going to store it with the name client. And then immediately after, we're going to use that function that we explored earlier, which is the connect function. I'm providing my personal credentials. We didn't get a warning. That means we're connected.
No news is good news.
So that's good, yeah. Now, the first function that I'm going to run here is the schema. There's an endpoint. Again, you'll find this all in the API documentation. I've added, as I said, I kind of like created this client very selfishly, thinking of myself. I use pandas a lot, so I included in the client pandas to get already like the responses instead of a JSON, which sometimes is not easily, it's not as easy to read for humans as it would be probably a pandas data frame. So I included this option that allows you to get the output of your calls as a data frame. So in this case, I'm going to run the schema function that will get me all the tables that I could query with my current credentials. So there you'll be seeing here probably more tables that you would see with regular customer credentials. But if you do this, and you'll know, oh, I have access to this table. So that's kind of good to know. And then if you want to have the specific data,
and this is a relevant point, the authorization that has been, or all the permissions and authorization within the API is on a per user and per role basis. And so if we started, we're not going to do it in here, but if we really got into creating API keys and assigning them to people, you can allow people to manage the users in an organization, but deny them the ability to look at the data. You can grant people the ability to read the data, but not look at the users in the organization. And so it's inevitable that any particular person is going to be able to see different parts of the API depending on the permissions that they have. And it's obvious you can't look at my data and vice versa. But some of these endpoints are richer for some people than others, depending on their role.
Exactly. Now, if we want to look into one specific table and get the data dictionary, I think we are all curious. This will get you the most updated data dictionary for that particular table. So in this case, I'm looking at hourly. If I wanted to look at daily too, I just pass that and I will get it as a pandas data frame that is like easy to read. So, and even if we update variables or add maybe variables, you will get the most updated ones here, querying using that function. So we'll see the column name, the data type, and the description, and the units for that particular column.
And this is one of these funny things where, you know, on the one hand, it'd be nice to just have a data dictionary that we could hand out. We found that we were continually refining it. We're adding new variables, changing their definitions in subtle ways. And then, you know, some tables different people get to see. And so the way that you access this data dictionary for most users is by way of such a client, you know, talking directly to the API, as opposed to, you know, asking you or me.
Correct. So yeah, this is great. Then now let's actually get to some actual data. So here, well, first we're gonna see some of the latest sort of data per devices. This, you're gonna see the devices endpoint that we used earlier. We're gonna run it and we're gonna see all the devices that I'm allowed to see with my credentials. And you'll see a little bit of data on the device, the last battery percentage reported, where it is, the firmware ID, the state, the signal strength, etc. So you'll find that all there. But I think from this table, it's important that we can get all the names, for instance, or all the device IDs for the device that we have. So that's important, well, both because it has a little bit of health data on the device itself, and also if we want to just grab the device IDs from here.
And some of these are familiar from looking at the app, the user interface. These are reported in different ways graphically, but this is just the primary table from which the user interface is developed. All right.
Okay, and now what I'm gonna do.
The big one, the data.
The actual data. So I'm gonna take, because I'm, you know, I want to just use all the names that all the devices IDs. I'm gonna grab the column name, and I'm gonna put all of those devices here in variable called devices IDs, and then I'm gonna pass that to the function data, which takes as an argument, well, the table that you need to get. In this case, I'm querying the daily table, followed by the devices. You'll have to pass a list. And then you have several, well, and you can see that in the documentation. You have the start time, several parameters. You can see them all here. If you actually just want to get like certain variables, you can select and like maybe not get all the columns. You can also play around with units right away as part of a parameter right there. So all of that will be sort of like the arguments. I'm just going to make it with
and all of that is written up in the API itself, or that documentation.
Right. Yeah.
That you showed us earlier.
Yep. So I'm going to go ahead and run this, which might take a little bit since we're talking about a lot of devices.
All right.
And here it is. So we get a daily table that, as we already looked at the data dictionary for it. And we're getting this for all the devices that I'm able to see. That's starting with the start date of March 1st until basically they stop reporting, or till today if they're active in the field. So I get this again. I'm seeing this way because this a pandas data frame object. It's kind of nice to see it, how it displays in Jupyter Notebook. That's why I love it. And after this, well, you can go off and do whatever you want with this data. So you can start already exploring it, cleaning it, plotting it, do whatever you want with it. So that's basically the example for getting the data. And then from then on, you can go ahead and do whatever you want with it.
Cool. And this I think of as, you know, the get done with this step as soon as possible so we can get to the next part, which is looking at plotting the data.
Yeah, and now that's what we're gonna do. So how about like 4 plotting examples that are interesting, some things that you can do with pandas and using Plotlib and so on. So this is basically the same imports that we had before. The same, we can call it login that we had before. So we've been authenticated. Now we can start querying data. So in this case, I'm querying 3 devices. I'm getting the daily data for these devices with a start and end time. And then what I'm doing next is converting the time column into a pandas, well, into a datetime object. So what this does is it makes it easier than for Matplotlib or within pandas to, if you want to aggregate using the time column and everything, it's much better and much more efficient than if you're passing it as a string. So
by default, everything comes back from the API as just text. And
exactly.
so, you know, if we look at any particular date, 2019-04-22, you know, that could be, you know, the name of my cousin for all the computer knows, until we tell it that it's a date time. And then now we can, you know, group things by day or
Yeah,
plot it. So.
exactly. So then let's use, well, I'm gonna plot these 3 devices that I have. And one interesting thing that we can do here, for instance, is I'm plotting the NDVI curve of these devices that were on top of some processing tomatoes. And I'm plotting it with the growing degree days at the bottom. So I think that's pretty interesting because you can, just by looking at the NDVI, and then if you get from your textbook the growing degree days per stages, you can see sort of the changes in the NDVI that correspond to each stage, and you basically can label it. So that's what we're doing here. So we grab the 3 daily data set for this 3 devices. And if we look a little bit at the code, we're setting as a subplot figure. So we're setting like 3 different plots basically.
Mm-hmm.
Then what we're doing is iterating over the 3 devices and over the 3 axes, that is sort of like the 3 subplots. So what we're doing in each one is we're first plotting a scatter plot of the GDD, but using cumulative sum. So we're summing each, like especially starting day 1, it's a cumulative sum until we get to the last day. That's going to be for the x-axis, and then for the y-axis, we're plotting just the NDVI. Gave it green as color. Then I set up some vertical lines. This correspond to the cumulative growing degree days per stage. So for bloom, for mature green fruit, and for pink fruit. Gave it some different colors. You can also add some labels. Well, the labels are actually down here. And that you can change the line style, so on, added the labels to it. And yeah, and then you can also label your axis, and that's basically one interesting thing that you can do with the daily data.
What I like about this is
Then
that it's, it's combining two different parts of the data. We've got the spectral and the temperature, lightly processing the temperature in terms of taking the cumulative sum, but then relating it to this external reality of A, when did a person plant these tomatoes? And B, what did a researcher define as being the kind of growth stage transitions? And so, what you're describing is synthetic of pulling in mark data, pulling in user data, and pulling in research data to create something that is, in this case, actionable because irrigation decisions on deficit are driven by the timing of that pink fruit transition.
yeah. Then the next example, we're basically doing a little bit of the same. We're grabbing some other devices. And this is interesting because one thing that, for instance,
And just a time check, we've only got a couple minutes, so.
Real quick, you can see this is again NDVI, but you can see it across different fields and compare it to some of the inputs that in this case, the ETC. These are the 4 collocated fields. So we're kind of seeing like how the health of the canopy responds to making sure here we're getting sort of like the same evapotranspiration. So we kind of can assume that we're getting some of the similar inputs, but seems like one field in this case has some issues. So that's something that a researcher or a field manager can look at. And then there's another example that I thought was interesting, which is combining a little bit of data that we wouldn't find in the web UI, which is the leaf wetness and temperature here. So we're setting leaf wetness data at the bottom, which is in hours, the hours that the leaves are wet. And then we have here the mean, min, and max temperature. So this could be interesting for maybe setting up a disease model if you set the right thresholds. So yeah, those are some examples that you can work through.
Love it. And that obviously you kind of glossed over the reference to the UCIPM website, but there's a huge number of different disease models, many of which relate to, some combination of being in the right zone temperature wise and for a certain duration of time. And leaf wetness is kind of the precondition for a disease outbreak. We do have a couple of questions. So let's dive in. Are there limits to how much data I can query? There is a default limit for how much, and you can override that in the API for asking how many rows to return. And in some cases, when there's a lot of data, there's pagination. And so you can ask for subsequent pages. But by default, as far as I know, you can grab data going back to the origin of the company through the API. Am I embarrassed by taking my glasses up to read closer? Not really. How does Arable deal with API keys? I don't use Jupyter Notebooks, but want to pipe data from my marks to other platforms. So can you draw up the documentation and go to the section on authentication?
Although this might be better.
I think it's, yeah, scroll down. The guide, okay, and right there. Actually, there's a section over there on the EULA. We didn't talk about this. You have to sign the EULA. There's a subtlety. A lot of folks say, there's an issue here. This is not working. It's, rejecting me. There is a EULA requirement, basically. So you have to log into the web app first and accept the EULA end user licensing agreement, and that is a precondition to using the API. And I say that not as a administrator, but just as an API user, it's a little bit of a gotcha. So going into authentication, and again, we're at developer.arable.com. So from the top, there's basic auth, which is what you showed us. And your credentials that you put in the header are this basic. It actually returns to you if you log into the auth endpoint, a bearer token. So if you scroll down, okay, so the endpoint here is API v2/auth/token. We're asking for that token by giving it, we give it the basic auth and it returns to us this bearer token, and that persists for a long time. You can store that somewhere. And if you scroll down further, now here's API keys. So there's an actual endpoint for creating API keys. Continue to scroll down. Okay, so there's an API reference for creating it, but scroll down a little bit further. And you can see that there's a lot of different scopes. So pause. Right here, there's data, read access, there's write access, there's orgs, there's users, there's teams, there's notifications, there's annotation. So all the different kind of endpoints in the API, there's this read or write access. And so any one key, you can give a lot of access, or you can have a key that only has a teeny bit of access. This is purely just for data, and you can't look at locations. You can put a termination date on it, and it's suggested to do that. You can leave an unlimited termination date. So you can give a different API key to a bunch of different people. You can make one API key that has kind of unlimited access. So that's the story with API keys. Thank you, anonymous attendee. Can I generate CSVs for all of my devices in one call? Go ahead to that data query example.
Yes, that's actually exactly what I did. So for all the devices that are listed here, I created one. Well, in this case, you can make it a
and
CSV.
two CSV paren file name .csv, whatever it is.
And then that will create a CSV wherever you're hosting
Wherever
this.
it is, it writes that CSV. You can subset it, only doing certain columns, so all the data frame manipulations, and then write that CSV. I use this all the time for scripting up. Hey, are you guys going to make everyone's data available in an anonymous way so we can do benchmarking against other growers similar to us, perhaps a data marketplace? Cool answer. Right now, the closest that we have towards that concept is around, we've got a CalVal network, and we've got a number of different researchers that we work with. Some of them are receptive, open, however you want to call it, to sharing data. There isn't necessarily a privacy concern. It's, land grant institution, federally funded, all that type of stuff. So that data we see as being open and, useful for prototyping and exploring. We don't really have a mechanism for making other people's data available sort of anonymously. And you know, uh, um, there's a couple sort of thoughts that I've had around this. One, obviously, somebody has to really want to allow you to do that. One of the ideas that's come up is, potentially there's a collective benefit for if NASA has a project where they're trying to improve Landsat, then they might benefit if more people shared ground-based spectroscopy to help them improve their algorithms. And, one could, ask, does anybody want to share access with NASA, a specific user for a specific use case? And if you want to, you could opt in. We don't do that, but that's sort of one idea that, we could imagine how to create a collective benefit. And the idea is, that would work if the benefit would go back to the user. Maybe people want to share with their university extension. These kind of opt-in networks. Other ways that data sharing is kind of, it's pretty hard in practice because, these have a GPS in them. So it's got a location. A lot of the value is that it can be tied to other geolocated data. So for example, if we know the coordinates, we can go, connect it to a weather grid. We could go connect it to satellite remote sensing. We can go, access Sergo. So there's a bunch of useful stuff that is kind of uniquely enabled by having those coordinates. But, from an anonymous, perspective, that's the most sensitive part that people would potentially not want to share. And so I've never really, gotten around how to balance that to the point of never having broached it with our growers. Do you want to make your data available? So there's maybe a third approach to that, which is, let's say a group of people all live in a valley that, there would be a collective benefit if you knew that, a disease or a pest is creeping in from one end to the other. Then is it possible to create a kind of a gridded product that doesn't expose any one person's data, but instead provides a kind of broad benefit to, members of that network? Anyhow, if anybody has ideas for ways that are, let's call it innovative, while honoring kind of user privacy, I'd be excited to explore all that. Right now, it's just at a, conceptual discussion stage, but obviously this idea of how is more better. So one of the ways to share ideas is my email, Adam, ADAM, @arable.com. Walter, what's your email?
My first name, Walter, Jove, my last name, Jove, @arable.com.
Great. And so you can reach out to us, and there's probably other ways on social to create ideas, but we're always receptive. So if there are no more questions, then I think we can wrap it up. I think there's a little bit of housekeeping. The intent is to have a show next week, but the speaker is not finally confirmed. So let's leave it open-ended. the future topics, if you have ideas for people we could interview, exciting, digital design, then absolutely let us know. And we'll send out a questionnaire and you can give us your ideas then. So until next week.
Bye.
Thank you.